Hello everyone. So today we're going to explain what is binomial distribution. What is binomial distribution in Six Sigma? That is we're going to explain in today's video. First of all, I will start with an example to make you understand the concept of binomial distribution. Now, the example is that now suppose you are inspecting 10 products. Okay? Now there are 2 defective products you have found out of 10 products. Now, what is the probability? What is the probability of finding out the defective products out of the 10 inspected products? That is being done by binomial distribution. Okay. So binomial distribution, it is a powerful statistical tool that helps Six Sigma professionals predict defects, improve quality, reduce risk, and make confident process decisions using probability statistics. So in this video, we're going to cover what is binomial distribution, the difference between binomial distribution and normal distribution, why it is important in Six Sigma, practical examples, key advantages and common mistakes to avoid in binomial distribution. We're going to cover all these things in our today's video. So first of all, I will start with the definition of binomial distribution. I've already given you an example to make you understand the concept of binomial distribution. Now I will go with the definition of binomial distribution. So a binomial distribution, it is a probability distribution that predicts the likelihood of 2 possible outcomes, success or failure, over a fixed number of independent trials. See, in binomial distribution, there should be a fixed number of independent trials. That is denoted as n, number of trials n. And there are 2 outcomes possible in binomial distribution. That is basically success, failure, yes, means success, failure. So that is basically defectives, non-defectives. This type of outcomes are possible in binomial distribution. Okay. And binomial distribution is applicable for discrete data. It is not applicable for continuous data. Okay. So hello, this is Surajit Banerjee, a Lean Six Sigma Master Black Belt. I welcome you all to our channel, the Lean Six Sigma World, the go-to place for mastering the concept of Lean Six Sigma in all aspects. I have written these books. These books are Amazon #1 bestseller, and I have achieved the Amazon #1 best-selling author from Amazon. Untold Story of Lean Six Sigma, this book will be a comprehensive guidelines for you to learn and master the fundamentals of Lean Six Sigma in one single go. This book will be a one-stop solution for you to master the fundamentals of Lean Six Sigma. Now, if you want to find out what are the losses involved in your machine shop department, in the manufacturing department, how to improve productivity, how to improve efficiency, how to calculate all those losses, then you should go for this book that is basically world-class OEE, that is overall equipment effectiveness. Now, the most important topic of my entire Lean Six Sigma journey is basically the 5S. So 5S is the foundation of everything. That's why the book I have given name as the power of 5S. It's applicable everywhere. Okay. So if you want to explore how it can be the foundation of everything, then you should explore this book. The links of these books are given in the description section. Now, I am moving into my next concept. That's basically why binomial distribution is important in Six Sigma. Because it helps quality professionals to analyze defective products versus non-defective products. It helps to estimate process performance, and it helps to make data-driven decisions based on the real actual data to improve the quality. Now, I'm moving into the conditions for binomial distributions. See, binomial distribution is applicable for discrete data. There should be a fixed number of trials, that is basically n. Only 2 outcomes are possible, like defectives, non-defective, success, failure. Okay. Now, independent trials and same probability of success, P, should be there in every trial. These are the conditions for binomial distribution. Now, the next one is basically practical manufacturing example. Now, if a batch contains 20 products and each has a 5% defective probability, then binomial distribution predicts the chance of getting a specific number of defective items. It basically it predicts the chance of getting a specific number of defective items out of the 20 products that is there in the batch. Okay. If the probability is basically 5% defect probability is there. So it basically helps to find out the chance of getting a specific number of defective items. Now I'm moving into next concept, is basically applications in Six Sigma. So it is used in defect analysis, process capability study, acceptance sampling, risk analysis, reliability study, and quality improvement projects. Now, key advantages: it is simple to understand, it predicts defect occurrence, supports quality planning, helps reduce process variation, improves the decision making. It also helps to improve the quality. And common mistakes to avoid in binomial distribution: it is used for discrete data. So if you are using it for continuous data, then you are doing a mistake. Ignoring trial independence, changing probability during trials. The probability should for each trial should be same. So if you are doing if you are changing the probability trial, then during trials, then basically you are doing mistake. And it is applying only for two outcomes. But if it is applying for multiple outcomes, then you are doing a mistake. These are the mistakes that you should avoid. Now, the binomial distribution versus normal distribution. Normal distribution is applicable for the continuous data. Binomial distribution is for discrete data. Okay, that is the basic difference. So, I just want to say that if you found this video helpful, make sure to like the video, share this video, and comments below your thoughts on binomial distribution. Whatever you learned today, share your experience in the comments below. I'll be very happy and obliged to see your comments. And you can join our exclusive WhatsApp community also to get free updates on Lean Six Sigma tools and techniques, everything for free. And subscribe to our channel and turn on notifications for more insightful content. And I just also want to take this opportunity to thank you all from the bottom of the heart for being part of this journey with the Lean Six Sigma words. Thank you. Thank you so much.